it should work exactly like before.
Perfect.
Okay. Now, the reason we did that is that iterators have a nice method called enumerate, which instead of returning the item itself,
Returns its index.
it returns a tuple
Oh, okay.
of the index and the item.
Oh, okay.
So if you, after each of these iter calls, you just add dot enumerate, so you can chain these. So this is what's nice about methods. I think we talked about this maybe in the first video or maybe last week or something,
Okay.
where you can do mol dot atoms dot it, or no, we looked at this in P's Q's,
Oh yeah. Okay.
where you can chain the calls to these methods.
So I do moles.atoms.iter.enumerate.
Yes.
What happened? Hello? Okay. Oh, I see what I did. Dot enumerate as iter.
Yep.
Like that.
Yep, just like that.
Dot enumerate.
And now, yeah, the type hint is actually helpful. The type hint is helpful here. You see that atom I is now a U size and an atom.
Yeah.
So if you actually look down a little bit into your main function, you can see a way to unpack a tuple into two different things.
Yes, I can see that. Yes.
All right. Now apply that pattern here. Well, actually, go ahead and try to run it. Go ahead and try to run it because it's not going to work.
Perfect. Uh-oh. Oh.
Does that make sense?
Yeah, no field X on type U size ref atom.
Okay. Yeah, so like I said, and like your type hint says, atom I. Uh-oh. Are you there?
Yeah, I'm good.
Oh, okay. What just happened? Are you there?
Yeah, I'm here. Can you hear me?
Oh, I think my Brent too just got like completely disconnected from the meeting.
Oh no. Just straight up obliterated, huh?
Yeah, hold on. I'm gonna leave the meeting from Brent too.
Oh, Brenterated.
All right, you're still there?
Yeah, I'm still here.
All right, hold on. I'm gonna have to let me duplicate the tab again.
Dup tab, dude. Dup tab.
Oops. Okay, you there?
Yeah, I'm here.
All right, sorry about. Oh wait, hold on. Okay, there we go. Now I'm full screen.
Wow.
All right, what the heck? That was weird.
Yeah, it was.
Okay, so the type hint is telling you what happened.
Yeah. So X belongs to the atom, right? It doesn't belong to the U size because the U size is the index.
Yeah.
Okay. So I have to unpack it.
Yep.
How do I unpack it if it's like a for loop? Like
it looks a lot like the thing down in main. That's why I told you to look there before.
Okay. So what do I
sorry, but you can do it in the for loop. You can actually destructure or unpack. Okay, hold on, you're going the wrong way. Oh, colder, colder, warmer, hot, on fire.
Okay.
Yeah, you can do it right there. This might be kind of confusing. This is kind of magical as
Would
well,
I say like okay, all right. Can you
just give it a guess? Give it a guess.
I mean, would I say for let?
No let.
See, okay, perfect. So
because you can think of the for loop as introducing a binding just like let. Give it a guess. Give it a guess. Yeah, hot.
Okay, wait. So what I well, so atom I want that to correspond to ref atom though, right?
Yeah. So that's the second element in the tuple.
So for comma atom I in atom in this.
It's beautiful. There you go.
Man, this is crazy stuff. Oh no. Okay. Okay.
Great.
Perfect.
just to mention this, you gave them both the same name.
Oh, I see. I see how that could be a problem. Well, this is just index I, and this is just index J. You know.
Yeah, there you go.
Perfect. J.
Okay. So yeah, why don't let's debug all three now. You can do index I, index J, and BL.
Oh, nice.
And then,
okay.
Yeah, now your output's going to start looking more like what they print.
All right. Index, indexy, indexj, and bull.
Personally, I probably would have called them just I and J, but yeah, no problem.
Man, look at that.
Yeah. Yeah, so enumerate is quite handy.
Yeah, that is kind of that's cool. Oh, I see. Okay, that's neat. So there's the bond length for atoms 0 and 0.
Yeah.
Yeah, yeah, right. And then 0 and 1, 0 and 2, 0 and 3, 4, 5, 6, 1, and 0. Okay, cool.
So something you've noticed here is you're computing the bond length of something with itself.
Yeah.
If you wanted to skip that, do you have any ideas what you might do?
Well, I mean, I would assume that I would need some form of like if statement.
Yeah.
So like if I equals J.
Yeah.
Don't do this thing.
Yeah.
Or I could say if I does not equal J.
Yes. Okay. Sure. Yeah.
So like would I put that here? So like if index I?
Yeah.
Oh, nice. Okay. If index I does not equal, is that how I do that in index J? J's right there. Then do the stuff here.
Perfect.
Nice.
There you go.
Nice. Oh, dude, that's so cool. Nice. So what about these okay, so index I and index J 0 of 1. This looks like it's doing the same thing down here.
Yes.
Okay. So how do I tell it not to do the combination or the same but backwards combination? I don't know how you phrase that.
So the easiest thing to do is probably to adjust your if statement.
The current if statement?
Yeah. So yeah, you can loop it into this. I think the other ways would be more complicated. So you could change what you're looping over. The other thing you can do, I picture this like a matrix actually.
Yeah, I just want the upper triangle of the matrix.
Exactly.
Yeah.
So what you can check, so right now you're checking that you're not on the diagonal.
Right.
Just not equals.
Yeah.
So instead of not equals, you could say greater than or equal, or less than or equal.
Oh, okay. Is that so if I wanted to do just greater than or equal to like this?
I think I actually said it backwards. I think since you're printing it when it's not equal, you actually want to either print when it's less than or greater than. But you can try it. Again, this is like, you just try it. I don't actually usually think about these too hard. I just try it and it's like, well, that doesn't look right, so I'll try a different one.
Okay.
So yeah, you'll see now because you put less than or equal, it's printing the equal case again, so you just take out equal.
Oh, I see.
So yeah, and either less than or greater than will work.
Oh man, look at that. Oh, that's cool.
Very nice. Yeah, and I think that should be basically what they print out.
Yeah. Does this also take care of whether or not these atoms are actually touching each other?
No. I think they like hard code a check that the atoms are less than 4 angstroms apart or something.
Oh, Okay.
So you probably have a little more output than they do, but
Okay.
yeah, that's something they don't even mention in the instructions, right? Like that's only in the solution.
Yeah.
But
Well,
yeah.
because
But
I
yeah,
mean,
you can do that if you want.
because I mean, I would feel like you would only want to calculate the bond distance if there are two atoms that are bound together.
Well, so they don't actually check that. Now now in my work, now actually, I mean, this is kind of an interesting thing that we don't think about when we're doing ab initio calculations.
Yeah.
Because in ab initio calculations, you just throw the coordinates in,
Yeah.
and it figures out where all the electrons and bonds are, like for you.
Yeah.
When doing molecular dynamics, you actually have to think about what atoms are bond together.
Yeah.
So a lot of the times, or all the time, we have to come up with what they call topologies, or basically graph representations of the molecule that encodes all of the bonds.
Okay.
So this, I mean, the 4 angstrom is like an arbitrary cutoff. It doesn't actually check that they're bonded.
Yeah.
But to check that they're bonded is a very difficult problem.
Oh no. Okay.
Yeah.
Well, then we can move on. That's fine.
Yeah. But I mean, if you want to go look at their solution, and I think it might be nice to print these in a little bit of a better way.
Okay.
We can talk just a little bit about string formatting if you want.
Sure. You want to talk about string formatting, and then I think we can call it a day.
Yeah, sure.
Okay. So, let's talk about string formatting then.
Yeah, so you've got the basic idea down below with the print line.
Okay.
So let's start with something like that. So instead of debug, let's just do print line.
Okay. Okay.
Okay.
So
now apply what you learned from your other print line right here.
And I'm assuming that, is it the same case where like this one thing corresponds to this one?
Yes.
So I need to have 3 sets of those?
Yeah. Okay. And the compiler will actually help you with that.
Oh,
if you only put one, it would be like, whoa, there's only one.
All right, well, let me try that just for fun.
Yeah.
Okay, cool.
But it is only one string. The first argument is a string literal, so you need multiple sets of curlies inside of one string.
Multiple sets of curlies. Oh.
I should have let you compile it, because that you would have seen that would have actually made the compiler more mad.
So like this?
Yes.
Okay. It would have made the compiler.
Precisely. Now, if you want to line them up nicely,
yes.
Inside of the curlies, you can put a colon and then a width.
Oh, nice.
So this will probably be most pronounced, in the first one.
Colon and then a width of...
Yeah, we love %5ds, so let's give it a colon 5.
Okay.
So that's how you do it in Rust. So like instead of Go or C or whatever, where you do %5d, in Rust you just say colon 5.
Nice. Look at that. That's cool.
Yeah.
All right. So now, what if I want to? Would it be the same? Okay. So would colon 5 for the BL reduce?
Yeah.
Not reduce, but like would it cut it off at the 5th decimal?
No, it will cut it off at a width of 5.
That's what I meant, not decimal, but
yeah. If you want to adjust the precision, you put a dot. So you could do 5.2 or something, or 12.8. You know, I guess that's what we use a lot.
Yeah. Look at that. Look at that.
Nice.
That's so cool.
There you go.
Man, that's neat. Cool.
All right, so let's recap what you've done so far, because you've done a lot.
I have done a lot, yeah.
You read a file. So in this, okay, and I think it's important to recap here, because what you've done is very useful for any project, basically.
Yes.
You've read in a file. You loaded data from a file.
Yep. You
turned it into a struct that's easy for you to work with in the program.
Yes.
You've written a function that takes a struct and does some data manipulation on it, and then you've printed it out in a nice format.
Yeah.
So that general scheme is actually what most programs are. Real world data, convert to a useful structure inside the program.
Yeah.
Do some kind of processing on that structure, output it in a nice real world usable format.
All right, that's cool.
So there you go. You've basically conquered all of programming.
I'm so proud. I'm so glad that I've conquered all of programming. Well, I guess this is the end of the series then. Oh man.
I think you're right though. This might be a good time to try Advent of Code, because that'll give us you'll have like a fresh start.
Yeah.
With all of your newfound insights. And it'll just be some practice on some of the basics that we just did. Like Advent of Code, you always have to load a file. You always have to spit out some output. So
yeah,
you don't always have to make structs and stuff in Advent of Code. Sometimes the problems are pretty simple, but
yeah.
But yeah, I think that's good. You feel good?
Oh man, I think I feel okay.
Well, that's all we can hope for.
That's right. Yeah, that's right.
Okay, cool.
All right. Well, I guess this is gonna wrap up at least this particular project. The whole thing. I'm not doing the rest. That's too much stuff. Actually, I think one thing that I would want to do is so we have to save, or we need to use we have to use the bond angles in order to do the bond. Sorry, the bond lengths in order to do the bond angles. Right?
Oh, I'm pretty sure they actually like recompute them.
No. Okay. Well, I mean, I'm assuming that if I wanted to save the bond angles, I would just save them into like a vector.
Yeah.
Okay.
One thing to consider, I guess, is that you might want to save them with their indices.
Yeah.
That way you can identify what they actually are later on.
Oh, okay.
So for that, you can use tuples again.
Okay.
Yeah, I mean, I don't know how quickly you want to get out of here, but we could do that. We could also...
yeah, let's at least save it as a tuple.
Okay.
That way, if we want to come back to this project later and finish that,
yeah,
that way it's already there and we could just go from there. So, like...
Oh, the one other thing I was going to suggest...
Yeah.
Is that when you're passing an argument like this, you see we have mole molecule?
Yeah.
We could define this as a method on molecule.
Okay.
And so then you would call it as mole.bond length.
Oh, neat. Okay.
So if you want to see how you just define a method, that would be a really quick change.
Okay, how do you do that?
So if you go up towards your molecule, I mean, you can do it right here, actually. Sorry, we won't scroll around. So the way you call it an impl. So we're going to implement molecule.
Okay.
So you make a block that says impl, IMPL, molecule.
Above the function.
Yeah, do it above bond length, because we want this to be inside of it.
Impl. Molecule.
Yep. Open curlies. Yeah, so this is a block, and then you put all of your methods or associated functions inside of this.
Nice.
And then close it after bond length.
Close it after, like the whole function.
Yeah, close the impl molecule block after the bond length function. Yeah.
Okay. Okay. And so now down here in func name, would I do like mole dot bond length?
Yeah.
Oh, so cool.
Yeah, instead of bond length mole.
Mole dot bond length, and I can get rid of this. Dude, that's so cool.
And that should work. Let's make sure. Ooh. Okay. So apparently to call it like that, you actually do have to change the argument to self.
Ah, okay.
So you can actually get rid of mole:molecule and just put self.
Oh, nice. Hello. Okay, there we go. Wait, I can do what? Mole:self?
No, you just change the whole thing to self.
Is it ref self?
Yeah, let's do ref self.
Swelf.
You can do plain self, but yes, ref self is actually good. But now mole is not defined. Now mole is called self.
Okay, so I have to do that. I have to change it in these spots too.
Yeah, you just write self instead of mole.
I don't want that. Oh, that's neat. Okay. Oh my lord. Self. Dude, stop that. Self.
Yeah, there you go.
Okay.
So great, you just transformed your function into a method on molecule.
Neato. Atom has a derived impl for the trait debug.
Oh yeah, it's still mad that you haven't used charge.
Oh, yeah. It'll be alright.
Yeah. What else were we gonna do? Oh, we made self. It's now a method. You can call mold.bondlink. What was the other thing? Oh, saving them.
Oh,
saving
yeah. Saving the bond links.
Okay, so now use what you learned up above about vectors and tuples to save and return the bond links.
I want to save and return the bond links and their indices, or the index.
That's what I would suggest. Yeah.
Okay. So that means that this function would need to return something. Okay. Yeah. And if I wanted to return the thing, so the index is an integer, right?
Yeah. It's actually the inlay hints are telling you what they are.
Oh, I see. Yeah. So would I say that it returns a U size like this?
Yeah.
Okay. And then this thing is a string, so F64. Right, that's what I want.
So do you want to return one of the indices or both of them?
Oh, both. So then I would want to do another U size.
Yep, perfect.
Nice.
Oh, and then do you want to return one of those or many of those?
Many of these.
Many of the tuples, right?
This whole thing is this whole thing being a tuple.
Yes.
I want to return many of them because I want to be able to access all of them. So would I need to change? Would I change these to the things? No, because that's for something else, right?
Wait, let's see. I don't actually know what you're saying. So let's see what you're saying in code.
What I was saying was,
yeah,
like this, or no?
No, that's a syntax error, but
perfect.
I think the idea is right. What do you want to do? So remember the angle brackets are greater than less than.
Yeah.
Are for specifying types. So it looks like you want to specify a type of something.
Yes.
And if you said you want to return many of them, I'm guessing you want to return a vector.
Yeah. Yeah. So I want to do.
So you are going to need some less than greater than.
Like this.
Okay, so this actually gets back to the first thing we did today. Do you want to return a tuple of vectors, or do you want to return a vector of tuples?
A vector of tuples.
That's what I would suggest.
Okay.
So in that case, you would leave the parens, you would add less than greater than on the outside.
I see.
And then you would slap vector in front.
I see. Okay. That makes sense.
That right there is how you write vector of tuple.
I see. Okay.
So yeah, I think you wanted to do the right thing, but you just didn't know how to say it, maybe.
Yeah.
Yeah, that looks good. Now it's obviously very upset.
Yeah.
Because you're not returning anything, but that's the only reason it's mad.
Yeah.
I don't know why it highlights the whole function, but it's like the whole function is bad. It doesn't return the right thing.
Yeah. I would want to do this outside of the for loop, right?
Yes, very good.
Right here. I'd want to return, or I want to do this, right? Or no, I've already, wait. I'm trying to remember how we want to do this. So if I were to return a vector of tuples, we don't have to push anything, right? I have to, I do need to, I do need to push stuff.
Okay. Yeah, so remember the pattern from earlier. We initialize an empty vector. Inside of the loops, we push stuff into it, and then we return the vector.
Okay. All right, so that means inside the loop, I need to push to a vector. But yep. I need to initialize an empty vector first, or we already did that because the return type is a vector?
No, in Go, you can do that trick, but in Rust, you do have to initialize it.
Okay.
Yeah, in Go, you can have a named return value, which implicitly initializes it.
I see.
You might be remembering that, I'm not sure.
I don't know. So let Let's see. What do I want to call this vector?
I often call mine ret, since I'm gonna return it.
Nice. Vec colon new. Okay. Vector of an unknown type. Do I want to be explicit with it here, what I'm returning, or does that matter?
No, it'll infer it once you actually use it.
Okay. So underneath here, could I do like ret dot push, and then I want to push index I, index J, and then the bond length of the two of them.
Beautiful.
And then now I want
the one thing you're missing there
is the semicolon.
The two things you're missing there. To construct a tuple, you actually do have to wrap it in parens, and it always looks weird when you do it with a push too, because you have to have two sets of parens.
Wait, so here and I put it here?
Yes.
Okay.
Yeah, because push takes one argument, so to make those three things into one tuple, you put another set of parens.
Okay. And so now underneath here, I want to return that. So I just
up one. Yeah, this is another confusing thing about the impl block, is it adds another set of curlies.
Okay, so now I want to
right there.
I want to return ret. Oh my.
Yeah.
Oh my lord. There we go.
Yeah. And actually you don't need the parens, because the reason we have parens above is because we're returning a tuple. This time just a vector, so you're good.
I can see here that it's going to want me to put mute probably.
Exactly. And you see your inlay hint actually figured it out this time.
Nice.
Now it knows the type of ret.
Okay. This is upset about something.
That's just an old error.
Cannot. Oh. Okay.
It doesn't update until you save it. Yeah.
Oh, okay. Nice. Yep.
There you go. Yeah, that was perfect.
Nice. And so now, because that returns something.
Yeah.
How would I? Oh, okay. Well, I don't know. But I guess we can talk about that next time if we wanted to move into it.
Yeah.
Okay. Perfect. Well, I guess.
Well, give it a run. Give it a run. Make sure it still works. But I think it should.
All right.
And as one trick, well, no, I guess we shouldn't do a trick. Never mind. It'll mess it up.
Yeah. No tricks. No tricks.
Okay. Okay. Great. Yeah. And now we can also, if you're interested, we can also do tests. So now that you're returning it, if we're just printing it, you can't really test it, right?
Yeah.
Like you'd have to like read what you're printing to yourself and then test that. But now that you actually are returning a vector, you can go through that vector and compare it to the output from the project.
Right.
Yeah.
All right.
So that's really good.
I guess I'm gonna go ahead and.
Yeah, commit that.
Yeah. Let's see.
Look at that. Look what you did. You took your little bond length comment. You made a method. Oh, it's beautiful.
Yeah. Man, I don't know what all to say. Made a bond length. Wow. Made a bond length method on molecule. I guess I don't need to say on molecule because you see it right there. Made a bond length method and additional refactoring.
Nice.
All right. All right, now it's, what is it? Is capital P for push?
I think so, yeah.
P, and we're done.
Money.
Well, I guess I think I'm gonna call it here for this video.
Yeah, sounds good.
I hope that this was instructional content for at least somebody out there. I hope it was educational. I hope somebody can relate to me when it comes to wanting to have given up, but obviously I'm pushing through now because I don't want to just give up because that seems a bit silly. But I hope that
I, for one, am very proud of you.
I appreciate it. So I hope somebody can relate, and if you do, I feel like coding is a very useful skill to have. So don't give up. Be better than me. Be better than me. That's what I want. I want someone to watch this video and go, "I'm better than that guy."
And next time, maybe we'll try to have some fun. We'll play Advent of Code.
Yeah, next time we'll have fun. This time it was just terrible. I hated my whole life. Oh, Jake, I'm just kidding. Okay, well, I thought that was fun.
Yeah, good.
I feel like once I got here and I realized I was like, okay, now I kind of know. I guess I understand. And once I understood what we were doing in this part, I think that I got it. Okay.
Yeah, I thought that was good. That would be the only reason I think to continue with bond angles is just to make you type that at least a couple more times.
Yeah,
but that's that might be overkill.
Yep.
Yeah.
All right. Well, everybody, I hope you had fun watching. Consider liking and subscribing. If you want to see more stuff like this, let me know. If you want me to not do this ever again, tell me. I can't fix what I don't know is broken. But anyways, I hope you guys have a good rest of your day, and I'll see you next time. See you later.